Hey there, this is Nacho here. So as promised, I'll be sharing a sort of overview of the technical stuff behind Dayglimpse. So if you haven't watched the other video where I explain the user flow and demo the app a little bit, please do go and check it out. But right now, it's all about how this was built. Um, so yeah, Dayglimpse at its core is actually a smart contract. So it's this dayglimpse.sol file here. So this is the file that the contract that governs the app flow. So this holds the day glimpses. Uh, you can set your day glimpse with it. You get it, you delete it. Um, you handle the minting of the NFT. You check if you're a mutual follower with the person whose NFT you want to claim. So it also handles the expiration. Like this is basically what handles everything. So um, things are clearer with diagrams sometimes. So this is basically the dayglimpse.sol contract. We have set dayglimpse, get dayglimpse, delete dayglimpse, mint NFT. So this basically triggers the minting. And in order to do this, this contract interacts with this interface. It defines this interface um, to another contract. Um, so basically, you have the minting capability here, which is mint dayglimpse NFT, and it has other functions that are also useful. Um, so basically, there's this other contract that that extends the LSP8 mintable that implements this interface, and this one is in charge of the minting and the ownership and everything else you can do with an NFT. Um, so the main one is the one that triggers it, and then when you actually claim the NFT, what you hold is a Dayglimpse NFT. Um, then there's there are other functions like is expired, checks for expiration date. Mark expired, what it does is if it is expired, it makes sure it's not there anymore, um, so that we don't have to check and delete um, the day glimpse when you get it or stuff like that. So this just makes sure that the get day glimpse is just a contract call and not a state changing transaction. Um, so that's useful for the UI as well. Um, so yeah, then our mutual followers. This uses the ILSP26 follower system interface um, to check if these two users interacting are mutual followers. So if a user wants to claim an NFT, they have to follow the profile owner, and the profile owner has to follow them back. So this is the function that actually checks that. And then there's this only mutual followers modifier that enforces that when attempting to mint the NFT. So yeah, what I'm using here is actually the LSP26 follower system contract, which I set via this setter here, which is only owner. So if there's another version of the contract and upgrade or another one that follows this interface that's better or whatever, the owner can change it. Same with the the NFT contract and the follower system contracts. So yeah, if you want to check some of the code, this is basically it. The iDayGlimpse NFT interface. So there's a bunch of functions here. Um, so it's not just minting the NFT, but also it's useful for another piece of the flow, which is this close friends or exclusive feature, right? Where we have to check if the person attempting to view this exclusive content actually holds one of these Dayglimpse NFTs. So there are functions that are used for that. Um, so you have the only owner, of course, the only mutual followers, which uses our mutual followers. Um, Events, uh, the different functions that we went through. So the set, get, uh, the get actually checks for expiration time. It checks that it is active, which basically means that it actually has some content. It's not, it wasn't deleted or expired or whatever. Um, we have this is private flag, which basically means it's exclusive. Um, so this checks for is close friend. Um, Mint NFT, which is only mutual followers. Mm, Well, this is basically the code. You can take a look in the repo, of course. Um, but yeah, see how it interacts with the interface and the contract address that we set, and it mints the NFT. Um, Mark expired, checks for expiration, and sets is active to false. Delete Dayglimpse just deletes the Dayglimpse, which, by the way, that's just a mapping. The Dayglimpses that should be here. You have a profile address to Dayglimpse data, which basically holds the Dayglimpse. So yeah, that's basically the idea behind the Dayglimpse smart contract. But now you have the full application, which is on Next.js. Um, and this is some sort of diagram, architecture diagram. Um, we have several components here. So there's the homepage where everything starts. Um, you have on the one hand an app layout um, and a profile context. Okay, so the app layout basically just uses some components and lays them out, of course. You have a connect profile that is related to that little thingy where you connect to your universal profile. The component itself is just like the UI part that's related to that. It checks some stuff there. And the profile page is what actually contains the main stuff, which is the image uploader, which is the component where you get all the interactions to upload the image and deleted and all of that. And you have the claim NFT button and the modal that pops up, of course, uh, when you claim the NFT. Um, so the profile context um, actually handles a lot of stuff. Um, you have well, the whole like connection to the universal profile, because you'll basically have two important things, right? One is the context of the parent application. So in this case, like universal everything. Um, so you have to differentiate between the profile that is connected uh, via the browser extension and the context profile. So you'll know stuff like, is the person viewing the day glimpse the profile owner? Is it just a visitor? All that stuff. So you have that. You have the well, basically the browser provider, the universal profile provider, and all of that to handle the blockchain interactions. And there are some generic functions that are used to actually interact with the smart contracts. So this is basically like um, the UP provider to interact uh, with a blockchain, and you have all things related to that profile and profile interactions with the blockchain, of course. Well, um, so yeah, this is basically exposed in this use profile hook, which is used um, throughout the application, but mainly in these use data glimpse hook, which just holds some functions that that interface between that low-level blockchain interaction and the smart contract definition. So this is the one that actually knows about the day glimpse uh, smart contract. This is just connecting a profile and exposing functions to interact with a blockchain, but it doesn't know anything about the specific day glimpse use case. Um, so yeah, these functions are then exposed in this hook, which is used in the use profile image hook, which uses some of these functions to set the day glimpse, get the day glimpse, delete it, all of that, and also interacts with an images API. The images API is defined in the same project, only server side. Um, and it's structured through it actually has a use case, which is the upload image use case, or well, there are actually a couple of use cases. You have the delete image, the set image or create image, and the get image, of course. And these use cases um, depend on this image repository interface. So I just wanted to show this. You'll see we have two implementations here, the IPFS image repository and the Cloudinary image repository, which is sort of dotted out like that. Uh, this is actually irrelevant to the actual application right now, but I just wanted to show this because I actually started out with this. I figured that to get things started, once I had the main smart contract and started building the app, it would be easier to just pick just a simple cloud storage solution for the images, make sure the whole flow worked, and then take care of the IPFS, which turned out to be pretty straightforward because we had this image repository interface. Um, So then it was just replacing one with the other. Um, so yeah, what this profile image hook does is take care of both um, interacting with the day glimpse hook smart contract via this hook and the IPFS stuff where the actual images will be stored. Um, so yeah, that's pretty much the bigger picture. Of course, you can go through the GitHub repo for more details. Uh, but yeah, this is there are a lot of files here, so don't know if it makes sense to go through each of them here. But yeah, you get the IPFS stuff. You have the hooks, like the get day glimpse, which interacts with the use profile, which basically this is what I was talking about. Um, these are like low level smart contract blockchain interactions. So you have one for calling a contract, sending a transaction, but they don't know anything about the day glimpse stuff. So you're sending the contract, the ABI, the address, the ABI, the method, the arguments. It's pretty generic. So yeah, that's pretty much it. There there are a couple of things that I came across actually when developing this, which were probably not solved in the best way possible. But I guess it's a good opportunity to talk about them. Um, so I had to come up with this uh, here with a pretty complex function to send the transactions. So this is here. See this send transaction low level. This is actually here to address a problem that I ran into. Um, see, before I just had this, which is pretty simple, where it checks that the signer is available. Um, well, if not, it tries to reconnect. Um, but this is the main part. So you have the contract. I'm using Ethers.js, by the way. From the address, the ABI, and the signer, you get this contract object, and you call the method with the arguments that you pass. Okay, so I was having an issue where, I mean, normally what you would do is this is the transaction, and then you get the receipt, which is this, right? And we would return the receipt. And this way, we make sure that anything we do afterwards, the blockchain transaction actually went through and it's all confirmed and everything. So I run into an issue that when interacting with a UP provider with a browser extension, you basically have two options, right? Let's see if I can show you here. I'll probably have to log back in. Yeah, let's say I want to do something here. Good. So I can either use the universal relayer for testnet or do the UP browser extension directly. Um, So what was happening here was that, wait, let's just cancel this for now. Um, when using the universal relayer, this promise was never actually resolving. The um, the transaction actually went through. I could move on with the app if I reloaded it. I could check uh, the transactions on the blockchain. Everything worked fine, but this promise resolution never never happened. Um, so then I tried with the other option, which is the browser extension directly. I had to do some pretty crazy stuff there. Not so crazy, of course, but I had to send over some licks to the EOA address that's handling this. Um, so when I did that, I could get this promise to resolve, but I couldn't get the receipt. So this allowed me to at least move forward with some stuff. I could just return this, which is what I was actually doing, hence why this return value was was this. So, um, but the bad thing about that is that I was actually moving forward with stuff from the UI before I was getting the actual receipt, so the experience was kind of funky. Um, so what I did, I came up with something that's more low level, which is this. So instead of using the ethers methods, I had to go with the interface, encode the function data, get the transaction hash, and then um, get the receipt via this enhanced transaction where I defined a couple of methods here. One, I didn't end up using this, which was more complex, checking the number of confirmations and stuff like that. But I ended up using this, which is not that complicated, but it seems like kind of more manual. So I wonder if you actually know about this, and and of course, I'd like to know what the correct way of interacting with it actually is. Um, and also for calling a contract, well, what I mean by this is like calling functions that are state changing, so it's only a contract call. Um, I also had to go for a more manual approach because I was getting an error. Uh, it's not just like the promise wasn't resolving or anything. Uh, I was directly getting an error because of the expected results was in a different format or something like that. I was getting like a full JSON RPC object when I should be getting a value, but it was failing like at the transaction level, like at the blockchain level, or actually at the library level. Like Ethers wasn't understanding the thing that I was returning, or something like that. I don't know if that's a known issue. But yeah, I went for this sort of more manual approach for both. So yeah, if you know anything about this or what the expected way to interact with smart contracts with the UP provider is, I'd like to know. Because the weird thing is that even when running like a script or whatever, I was able to interact with the contracts just fine, but it was specifically with the UP provider. Um, at one point, I came across a bug with the unfollow functionality, which was actually triggering the follow. So for this application, I actually needed to go back and forth between following and unfollowing someone. And at one point, the unfollow was actually triggering a second follow, so it was failing. It wasn't actually doing anything, it was just a warning. Uh, but that was actually kind of a fun thing because it was part of the learning experience. I had to do it programmatically, so that also let me interact with a smart contract and trigger that. But it was fixed, so it was easier for the demo later. Um, so, well, it's a pretty long one, but I had stuff that I wanted to share and ask you guys. Um, so, yeah, I hope that's helpful. This is probably way more extended than expected, but yeah, of course, if you want something more to the point, of course, you'll be able to read it on the repo and uh, the application and all of that. So, well, thanks very much for your time, and um, hope this is useful in some way.